I wanted to create a video that showed a visual way of finding all the roots of a complex number, and we're going to do the fourth roots. So let's do this one. Find all the fourth roots of -4 plus 4i. First, we're going to draw it because, again, this is a visual explanation. And one of the reasons we want to draw it is to put it into the re to the I theta form. So here's the picture. That blue point is our -4 plus 4i on the complex plane. Our magnitude is 4 radical 2, just by using Pythagorean's theorem, and the angle is clearly, that red angle, is clearly 3 pi fourths. So we can write it as 4 radical 2 e to the 3 pi fourths I. Okay, so now we're going to find just the first fourth root, the most simple one. Once we find the simple one, we're going to find the other three by spreading them evenly around the circle. By the way, the fact that you're looking for fourth roots means there's going to be 4 of them. And we'll talk about what it means to spread evenly around the circle later, but it's going to be a circle with a radius of 4 radical 2. Okay, so a fourth root is just raising to the 1/4 power. That's pretty basic in terms of properties of exponents. Apply them to both factors, right? This is one factor of the number, and this is the exponential factor. Apply the 1/4 to both. And in order to play with exponents and square roots, they're both a form of exponents, but they're a different form of exponents. So we're going to put the 4 radical 2 both back into exponential form. And properties of exponents, you multiply the exponents together. That's where the 1/8 came from. And of course, 1/4 times 3 pi fourths is 3 pi 16ths. And then we can put it back into the a plus bi form. By the way, if you don't remember where that 32 came from, you can always go backwards. You can rewrite 4 as the square root of 16, and then 16 times 2 is the square root of 32, and of course that's 32 to the 1/2. That's just a side note in case you were wondering where this 32 to the 1/2 came from. Okay, so this is what we have, and if we plug that into our calendar, we get approximately that. Of course, we're thinking about how to do this visually, so let's graph it. There it is right there, and that's the first one. And it's important to remember that the angle is 3 pi 16ths, this angle right here, 3 pi 16ths. Also, a little side note is if you type that into your calculator and raise it to the 4th power, it's not going to be exactly -4 plus 4i because we rounded, but it's going to be approximately. And so we know that we found the first one correctly. Okay, so again, this is 3 pi 16ths. Okay, so here's the picture again, and we're going to spread the other three around the complex plane, which will look like this, right? Can you see how all the angles between these guys, if I was going to draw angles here, they'd all be 90-degree angles or pi halves radians, and I'm talking about spreading them around the circle r equals 32 to the 1/8, or if you like the Cartesian equation for a circle, x squared plus y squared is 32 to the 1/8 squared, r squared. But the key thing is this picture, right? I don't have any numbers at all, but I know approximately or roughly just from the picture where all the other ones are going to be. There's one, there's one, there's one, right? Because they're always going to be spread around, and they're always going to be spread around evenly. All right, so let's start with a fresh picture. We know that all the angle between them is pi halves, and all we've got to do then is just add pi halves, right? We know that this first angle is 3 pi 16ths, so we add pi halves to that and we get the green angle. And do it again, and do it again, and we get all the different angles. And so notice all our angles are here for the re to the I thetas. We have 4 different angles now. And so we just plug them all in, right? There was our original 3 pi 16ths. We already had that one. But there's the 11 pi 16ths, this guy. There's the 19 pi 16ths, that guy. And there's the 27 pi 16ths, that guy. And we've got it. We've got all 4 roots without really needing to memorize any new equations. It's all in the picture.